So today's lesson is simplifying radicals. This is going to be a 2-day lesson, so today is part 1. This is out of chapter 10, lesson 2. So the product rule for radicals states that the product of two square roots is equal to the square root of the product. So we're just going to do some examples together. So your example number 1, or example I, is the square root of 4 times the square root of 12. So the first thing that we're going to do is actually use the product rule and multiply these together. So we can say it's the same thing as the square root of 4 times 12, which is the square root of 48. Now, we have to simplify this. This is not a simplified radical, and we want to simplify it. And the way that we do that is we have to think about perfect squares. So 4 is a perfect square, and 4 goes into 48, but 16 is also a perfect square. So 48 is the same thing as the square root of 16 times 3. Now 16 is the same thing as 4 squared times, so I have the square root of 4 squared times the square root of 3. And if you remember at the beginning of the year, we realized that when we take the square root of a square, the square root kind of cancels out the square. So the square root of 4 squared, or the square root of 16, is 4. So my final answer is 4 times the square root of 3, and we read that as 4 root 3. All right, let's do example II. So I have the square root of 15 times the square root of 10. So that equals the square root of, well, 15 times 10 is just 150. So now I'm going to break this up into perfect squares. That's the same thing as saying, let's see, I know that 150 is divisible by 25. So that's the same thing as saying the square root of 25 times 6. The square root of 25 is the same thing as 5 squared times the square root of 6, but the square root of 5 squared is 5 root 6. Okay, I have one more example that we're going to use just recognizing perfect squares with. So I have 6 times 18, or the square root of 6 times the square root of 18. So that gives me the square root of 108. I don't think my ink pen wants to work. The square root of 108. Well, let's see. I know that the square root of 108, or the number 108, is divisible by 36. It's the same thing as 36 times 3. So I have the square root of 36 times 3. The square root of 36 is 6 squared. It can be written as 6 squared times 3. And the square root of 6 squared is 6. So the square root of 108 is the same thing as 6 root 3. Now, you're probably thinking it doesn't look as easy as it is, or there's a trick to it, and there is a trick. The trick is to remember perfect squares. You have to know perfect squares. You have to memorize them. I remember at the beginning of the year I said it would be in your best interest to know the squares of the numbers 1 through 25. It's definitely important to know these. 1 squared is, so when I square it, it's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. We're looking for numbers that divide with this as a factor. We want these to be our factors. So making simplified radicals is easy if you can recognize perfect squares. Now, if you can't recognize perfect squares, there's another method. So let's do some more examples using the factor tree or prime factorization. So let's try this. So I have the square root of 15 times the square root of 30. Well, 15 times 3 is 45. So that's the same thing as the square root of 450. So I'm going to break that up into prime factorization. We're going to make a factor tree. So that's the same thing as 45 times 10. 45 is the same thing as 9 times 5. 9 is the same thing as 3 times 3. Prime number, prime number, prime number. 10 can be broken down into 5 times 2, prime and prime. Now, this is a square root, which means it's a factor or multiple of 2, right? It's that exponent is a power of 2. So I'm looking for a pair. Because it's to the second power, I'm looking for a pair of factors. So when I find a pair of factors, I'm going to circle them and I'm going to pull them out. So 3 times 3 is 9, and the square root of 9 happens to be 3. So I'm going to pull that out. I also have 5 and 5. I'm going to pull that out. I don't have a match or a pair with this 2, so that's going to stay underneath the radical. 3 times 5 is 15. So I have 15 root 2. So let's think about that for a second. Well, 15 came from what? Well, what is 3 times 3 times 5 times 5? 9 times 25 is 225. Well, let's check that. Is the square root of 225 times the square root of 2 equivalent to 450? Yes, it is. Is the square root of 225 in fact 15? Yeah, that's a perfect square. Okay, so let's do it again. Only this time I'm using a cubed root. So this is a cube, which means that I'm looking for 3 of a kind. So I have to have 3 of a kind in this example. So let's see. 16 times 72 is 1,152. So I'm just going to start breaking this up, and I'm going to reuse the factors that I just had, 16 and 72. So let's see, 16 prime factorization is 4 times 4, which breaks up to 2 times 2 and 2 times 2. So this is all the way factored. 2 times 2 times 2 times 2 is in fact 16. Let's look at 72. 72 is the same thing as 2 times 36. 36 is the same thing, so this is prime. 36 is the same thing as 2 times 18. 18 is the same thing as 3 times 6. And 6 is the same thing as 2 times 3. So I'm going to put an underline underneath all of my prime numbers so you can see where we stopped. So, and if you wanted to check and see if you did this properly, you could actually take 2 times 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 1, 2, 3, 4, 5, 6, 7th power times 3 to the 2nd power in your calculator, and make sure that you get 1,152, just to check and make sure that you actually did the prime factorization correctly. Okay, so now we're looking for sets of 3, like 3 of a kind. So I have 1, 2, 3. I'm going to pull out a 2. I have another 1, 2, 3. So I can pull out another 2. And then I have 3, 2, 3. Those are going to go back underneath. 3 times 2 times 3. Remember, all of this is multiplication. So 3 times 2 times 3. When I simplify this, 2 times 2 is 4. 3 times 3 is 9, times 2 is 18. So what did we actually have? We had the cubed root of 1,152. Simplified is 4 times the cubed root. So when I look at this, this is the same thing as 3, the cubed root of 1,152 is the same thing as 4 times the cube root of 18. All right, let's do one more example, and this is to the 4th root. To the 4th root, so I'm looking for how many? 4 of a kind. Okay, so 16 times 81. 16 times 81 is 1,296. So I'm looking for pairs of 4, right? So I'm just going to start with 16 times 81. 16, well, we already factored out 16 in prime factorization. That's the same thing as 2 times 2 times 2 times 2. And that makes sense because 2 to the fourth power is 16. Let's look at 81. That's the same thing as 9 times 9. 9 can be broken down into 3 times 3. 9 can be broken down into 3 times 3. I'm looking for pairs of 4, so I have 1, 2, 3, 4. I can bring out a 2. 1, 2, 3, 4. I can bring out a 3, and I don't have anything left. So that tells me that the fourth root of 1,296 equals 6, which is the same thing as saying 6 to the fourth power equals 1,296. Check it in your calculator, see what you get. Okay?